And it has to do with the fact that we have figured out what a bunch of these replication enzymes do. So, for instance, we can take our target DNA and we can take something called a vector and we can cut it with the same enzyme. And we do this with endonucleases. Two different DNA chopping enzymes, exonucleases so these basically chop from the free ends in. They recognize the ends of the sequence. And you have endonucleases. And these guys cut in the internal inside of the free ends. So if you have a chunk of DNA here, they're making cuts on the internal parts of the DNA, not on the free ends of the DNA. So what we can do is we can take our DNA, that's a target DNA, and a vector, and we usually use these with prokaryotes. These are called plasmids. I'll talk about this in a second. And we cut them with the same endonuclease. So let's sketch this out in a quick cartoon. Here we have jellyfish DNA. Oh, let's do it this way, make it easy. That way we can see the differences. So here we have our jellyfish DNA. We add that with this vector, which is a circular plasmid. And it's just this small piece of circular DNA we find inside bacteria. And we cut these both with an endonuclease. And there are a bunch of ones that we have found, and you can actually get a catalog and you order them, they come 24 hours. Let's just use one called HindD3 actually. It comes from the bacteria Haemophilus influenzae. That's the name. HIN. And it recognizes a specific sequence. Okay? So it's going to chop here, 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 and here. And it's going to chop just there once. After which, we can stick these together with another enzyme called the ligase, and it creates this recombinant DNA. So what we end up with is the plasmid opening up, and we get a chunk of our DNA inserting into our plasmid. So we have plasmid plus jellyfish DNA. And now we can take this plasmid, inject it into E. coli. Here's my E. coli. It's got its normal chromosome hanging over here, and it has this little plasmid hanging out. And it'll now replicate and express whatever we just stuck into that plasmid. So if it's the green fluorescent protein from a jellyfish, my E. coli will turn green fluorescence. If it's the insulin gene from humans, this is how you get insulin now. We don't like use pig insulin or harvest it from humans. We just take the gene for insulin, stick it into a plasmid, put it into E. coli, and E. coli would produce insulin for us. So this is kind of this recombinant DNA that we can kind of utilize during this process. The reason why? Because we learn about the enzymes and what they do, and then we kind of use them to manipulate the DNA afterwards. So I'm going to leave it there for today. We're going to take a